Go ahead.
All right. So this group actually added 5 instructions. First one's JNZ, so jump if the accumulator is not 0. So basically it either jumps if it's not 0 or it does not jump if it is 0. Jump if carry, so if the carry bit is high, it jumps. Jump if not carry, if the carry bit's low, it jumps. So these are all relative address commands, so that they will take whatever the next. These are all 2-byte instructions. The second byte actually is the amount of memory locations to be added or subtracted for the program counter to be actually going to. The last 2 instructions are linked. A call is an absolute call instruction. These 3 are relative. This one is not relative. This one is actually an absolute address. Once it gets to that particular 2-byte instruction, the second byte is the absolute location of the next instruction that it wants it to execute. And return actually allows the instruction, the return instruction actually allows the program counter to take the last instruction that ACALL was at and go back to it and then continue executing the program. So these 2 are linked. ACALL will take the second byte of the instruction and save it into a register bank. Return will use that register bank to recall the last location. And there's a 4x4 registers that are 8 bits wide that have the ability to allow up to 4 nests for ACALL. Beyond that, then the user needs to be able to limit it to 4. And the test program, basically we're going to set the carry bit. We're going to test that JNC does not work, so jump if not carry. Since carry is on, it should not jump. We're going to clear the carry bit, test the same thing for jump if carry. Then we're going to jump with ACALL to line 43, which is the first nest. And that takes us to this right here. We're going to add C. We're going to add 1 to the accumulator, so the accumulator will end up being 1. We're going to test jump of 0. We shouldn't jump because the accumulator is 1. Then we're going to go ACALL again, and we're going to go to line 13. It's the second nest. Line 13, we're going to move the accumulator's value into register 0. And then we're going to decrement by FF, so we're going to subtract 1. This is going to set the carry bit. We're not clearing it, but the accumulator will be 0. We're going to test jump if not 0. Again, should not jump. Then we're going to ACALL, we're going to go to line 31, which is right here. We're going to move the accumulator's value, which will be 0, 0. I'm sorry, we're going to move the register 0's value into the accumulator. This is 0, 1. So jump if not 0, this should jump. So we're going to actually go down we're going to increment by 2, go down to the next ACALL. And we're going to skip add C and the 0, 2. ACALL will then go to 6A, which is the 4th nest. 6A, we're going to move the accumulator's value, which the accumulator right now is 1, into register 1. We're going to jump if carry. Since the carry bit's already been set, it should jump. It's going to go down to, it's going to skip the set B. It's going to clear, or go down to clear C, which means it's going to clear the carry bit. Then we're going to jump if not carry, which again should jump. So we're going to skip the swap A. It's going to return from the 4th nest to the 3rd nest, to the 2nd nest, to the 1st nest, and then that takes us back to this location here. We're going to move 0, 0 into the accumulator, and then increment to jump 0, and basically this will loop indefinitely.
All right. If you want, you can speed up a little bit.
Every time we speed it up, it just sits there.
Okay, what's happening now?
Well, basically it's gonna so at this point we've set the carry bit right here.
Okay.
Also, LED G3 is when the registers for the ACALL and return instructions are enabled and their write enable is high. And this right here, G4 and G5, least significant bit, most significant bit of the counter. It's a 4-bit counter. So right now we're in register the 0th register, the write enable is low. And we can see that happen once the ACALL instructions go high. at this point, we did notice that it did not jump, which is correct. Now we're going to clear the carry bit with this instruction. So LED G0 is going to go low in the execute cycle, or falling edge of the execute cycle. And we're going to, again, test jump of carry, which again should not jump. So the carry bit now is low. Can you pull up the document? The report that we sent? I forget the... As we can see, it incremented properly, so it did not jump. So now we're in the A-call instruction. You see here LED G2, excuse me, G3 is the one we'll watch for the write enable for the register.
Okay.
So the write enable goes high in the decode cycle. On the falling edge, it will update, just like the program counter does. And now we've also already, at this point, we've incremented to the next counter position. So now we were in the 0th counter, now we're in the first register, excuse me, the 0th register, now in the first register. And now we're going to be adding. So we've saved the information as to what the program
So we have jumped to 43 now.
Jumped to 43.
Okay. Go to next page. Yeah.
Now we're adding 1 to the program counter, so this will update 0-1 execute cycle.
Okay.
There it updates. So the next now is going to be, we're testing JZ. So again, the accumulator is not 0, so we should be able to not jump.
Alright, so we are at 47. We call the next A call coming in.
So it did not jump, which was the way it was not, or the way it was supposed to do that. Now in 47, it's going to be A call. It's going to, again, we're going to see LED G3 go high, so the write enable now is high, and actually LED R9 is the second register's write enable. So this is the write enable for the bank. This is the write enable for the specific register.
Okay.
And again, we've incremented to the second register of
Again, looks like you have
0
jumped
through
to
3.
1-3.
Yeah, we jumped to 1-3.
And 1-3, you are moving A into R0. Can you show me the value of R0?
So this is the register 0, and then once it gets the next falling edge of the execute cycle, that will update. And there it updates. So now we've moved the accumulator's value to R0. I'll go back to the memory location.
Now we're going to decrement in the accumulator.
14, yep. Now we're going to be decrementing. So the second set right here will be FF. There it is. This will set the carry bit. Carry bit's been set. We're at 0, 0.
So now we're testing J and Z.
Right. So we should, again, because the accumulator is 0, we should jump of not 0, which means that we should not jump. So we should see nothing happening except 16, 17, and then going to 18. Okay, so now we're in 18. It's another A call command. Again, we're going to see LED G3. Again, we're in the second register, 0, 1, 2, 3. So this is the second register. It goes high. Here we can see LED R10, which is the second, or actually third register. And we're going to go in the execute cycle. Execute cycle, the write enable goes off. We've incremented to the fourth or third, whichever way you want to look at that, register. This is the last register. So we're register 1-1.
So we have jumped to
We've jumped to 31,
31.
which is the third nest. Now we're going to move the accumulator, we're going to move R0, the memory location R0 that we just saved, we're going to move it back into the accumulator.
Okay, can you show R0? All right.
R0 is here. And then on the falling edge of the execute, that will update the accumulator itself.
Okay.
Okay. Now, this 32 is going to jump if not 0. Now this should jump, so we will increment actually from 33, which is where the increment amount comes in. We should increment directly to 36.
Okay, so it's J and Z. Jump if not 0.
Correct. As you can see here, the B signal is high. It did the math. 36 is where we're at. We skipped 34 and 35.
And then we are on next A call.
Next A call. It's the fourth nest. And once again, we're right into the fourth register or the third register, whatever you want to call that. And right enable goes high. Here's the fourth register. We've already saved it. We move 6A into accumulator or the program counter.
And we are in the 6A, which is the fourth nest.
Yep, fourth nest. And now we're going to move the accumulator into R1. So 0, 1 going to be moved into R1. So here's the first register.
Okay.
Updates. Okay, now we're going to do jump if
Carry.
Right, jump of carry, excuse me. The carry bit is still set from the previous decrement. So it means that we're going to jump. We're going to jump by 1, which means we're going to jump to 6E. So we're going to skip 6C. Or D, excuse me. So this will increment not to D, but to E. And there it goes,
Okay.
to E. Okay, so we've cleared the carry bit, or this will clear the carry bit. So that'll go off.
Okay.
It goes off. Now we're going to test jump if not carry. So once again, it will jump by, so it'll jump from 6F, 70, and then it will jump directly to 72. So it'll skip 71. So we're incrementing it by 1 past the next on this. And there's 72. Now the return command. So the return command now will, if we notice here, LED G5 and G4 are 0 and 0, which is pointing to the 0th register. Well, that's not the register we want to point at. So the return command is going to decrement the counter, so which is going to go to 1, 1. And it's going to pull 37, which was the third nest's last location. And the execute cycle is going to add 1 to get to 38, and then execute the next instruction, which 38 is actually the next instruction.
Which is again a return instruction.
The return instruction. And then once again, we'll see here that, again, the correct address is not in the fourth counter or third counter, however you want to look at that. It's actually in the next counter decremented. So in the decode, it will decrement by 1. We've got the location now of that particular previous, and it's updated to 19, which is, we're going to increment that by 1, so 20. So we left off at 19, but we're actually supposed to go back to 20, because that was the one we needed to be at next, or 1A, excuse me.
That's the next return instruction.
Yep, so now we're in the second nest. It's basically we're down the chain, going back up the chain. And once again, we've got the counter here showing 0, 1, 0. Now it's 0, 1. So now we're going to go to the first nest, which was 48. We're going to increment by 1. 49 is the next command from where we left off. And there it is. Now we're going to execute what's in that, and that will be another return instruction. once again, we're pointing at the wrong counter, or wrong register, but it has decremented. So now we're pointing at the 0th counter, which is exactly where we're supposed to be pointing at. And we're going to return back to 07. And then after, of course, the return finishes and the execute, it's going to add 1 because the A signal is high. So 08. Now we're going to move 0 into the accumulator. Basically, we've saved the previous operations in the appropriate registers. It's going to execute 0 into here, and then we're going to finally test jump of 0, and jump of 0 will loop indefinitely. So here in the execute, we're going to see 1A, or sorry, 0A, and this is 0, 0. Accumulate now 0. Jump of 0. It's going to increment to 1B, or 0B, excuse me. There's the increment to 0B. Here's the FE. And here we have the B signal going high because, of course, the accumulator is 0, supposed to, and they're decremented. And it will loop from 0A to 0B to 0A to 0B for the next cycles indefinitely.